Welcome students to your favorite channel Pradeep Sir Classes has PSC, and today we are going through the numerical king series, that is AC Verma solutions, and this is Gauss'S law, that is the specific chapter name is chapter 30, and this is question number 13, 14, 15, and this is volume 2. And if you were first in that particular class, then go back to the previous lecture and enjoy all the numericals, and then come back for that particular number, that is 13, 14 and 15. And students, as I suggest you that the numerical king series, and there is also a series that is the classic text series, and most probably for 2 weeks we are not uploaded that particular videos, as we are engaged that particular series as well as the concepts of 11 and 12, and I will customize my channel with shortly, that is the respective series, there is a respective series and the relative 11th concept as well as the respective series, and then also the 12th standard concepts. Okay, and there is another course, that is IIT Foundations for class 10, and you can also enjoy that particular course. It is a very important and very much special type of numericals there given, and each and every numericals I explained elaborately. Okay, so let's continue with that particular series, the numerical king series, and the question number 30. So first of all, students, you have to take a habit of write down the numericals and then try and then see the answer. So write down the questions. Okay. So students, question number 13, and the 13 is first of all, I think that you are right on the questions, and this is a beryllium nucleus. Beryllium, what is about beryllium? This is a 4, and that is the proton number is 4, and if we go through the electronic configuration and consider the following very rough model of beryllium atom, and the nucleus has 4 protons and 4 neutrons and confined to a small volume. Volume of the nucleus is given. The radius is 10 to the minus 15 meter, and the 2 1s electrons make a spherical cloud. An average distance of this and 2s electron also make a cloud of 5.2 into this one. Find the electric field at a point just 1s and 2s. Okay. So students, if we go through the electronic configuration, then you have know that 1s2 and then 2s2. Why it is? Because beryllium contains 4 electrons. So 4 electrons means what is the distributions of these electrons? That is there are 2 subcells, the cells, that is 1s and 2s, and it makes a cloud of 1s. So if we draw this particular, I suggest always you that you first of all you have to draw that particular or figure out the numericals. So this is a nucleus. This is the nucleus, and this is the radius for that nucleus. This is the radius for the nucleus, and it contains 4 protons. Okay, so 4 protons means the nucleus contained a charge of 4 into 1.6 into 10 to the power minus 19 coulomb. Okay, so this is the nucleus, and it contains proton. Okay, and neutron, but neutron is a neutral particle. So proton and electron, and about neutron, all the fundamental particles, and proton is positively charged, electron is negatively charged, and the neutron is a neutral charge. So there is no charge of neutron. Okay, so this is 1s orbit, and this is 2s. So students, if you clear your concepts or point of view within these 1s and 2s. So focused on 1s electrons, 1s subcells, that is the clouds, that is there is a charge distribution of this one, which suppose I think it is an electron, so there is an electron cloud over it, and I think that is it is uniformly distributed over the sphere of radius, and the radius is given, and the 1s radius is it is 1.3 into 10 to the power minus 11 meter. It is 1.3 into 10 to the power. So this is if I say this is r, this is x. So this is x equal to 1.3 into 10 to the power of minus 11 meter, and this is 2s. So this is, if I say this is y, then it is given 5.2. This is 5.2 into 10 to the power minus 11 meter. Okay. So this is meter, and r is given. R is also given, and r means from that particular direction, that is the radius of the nucleus, and it is given. This is 10 to the power minus 15 meter. So again I repeat, students, you have to calculate electric field at that point, and you have to calculate electric field at that particular point. So you have to calculate electric field here and here, just inside the 1s cell and just inside the 2s cell. Okay. So first of all, students, when you have to know Gauss's theorem, that is E dot ds, that is closed integration of E dot ds equal to Q by epsilon naught. Q inside means the inside charge, that is the Gaussian. If we take this as the Gaussian surface, then what is the charge content within this surface? And if it is, you know that what is the charge content of this surface, then you can easily calculate electric field. So what is about Gauss's theorem? That is net flux equal to 1 by epsilon naught into Q inside. Phi net, that is net flux through a closed surface, is equal to 1 by epsilon naught times net charge enclosed within the surface. So that is the problem. So again I repeat or explain elaborately. That is, there is a nucleus and it contains 4 protons. This is the main point, 4 proton, and there is 1s orbital, and it contains a charge distribution of 2 electron. There is a 2 electron, and there is also 2 electron, because the configuration is 1s2 and 2s2. So it contains 2 electron. That is 2 into 1.6 10 to the minus 19. That is, it is a negative charge, and this one is also negative, but this one is positive charge. So if we calculate electric field at that point, then you have to apply a Gauss's theorem. That is if I use this one, that is for question number 1, you have to calculate electric field at just inside 1s. Then you have to integrate this one, E dot ds, and this is closed integration, and this is equal to Q inside by epsilon naught, and E and the ds means the surface area of this one is 4 by x square. So this is 4 by x square surface area, E dot ds, and if we integrate this one, then we get 4 by x square. This is Q inside. So what is the charge content within this sphere? There is 4p. If I say what is the charge content within this one, then you can say 4p minus of 2e, because this is proton, this is electron, so the charge is 2 proton is extra, because electronic charge and the charge of the proton is equal. Okay, so E equal to 4 by x square, Q inside means 4p, so 4p by epsilon naught, and you can easily calculate the electric field, and this is 4p by 4p by 4 pi epsilon naught x square. So 1 by 4 pi epsilon naught means 9 into 10 to the power 9 into 4 into p. P means proton, 1.6 10 to the power minus 19 by x square. So x square means the separation distance, that is the distance of the 1s orbitals from the center, that is 1 point something. It is 1.3 into 10 to the power minus 11. So 1.3 into 10 to the power minus 11, and this is square. So this is 1 by 4 pi epsilon naught, it is a constant, and 9 into 10 to the power 9, 4 into p means proton, charge of the proton, that is 1.6 10 to the minus 19, and this is plus by x square, that means the distance from that particular distance you have to take. Okay, so this, I think a point just inside the ones. So this is the case number A, and the answer is, and if you calculate this and this and this, you have to multiply this one. So 9 into 4 into 1.6 divided by 1.3 whole square into 10 to the power of 9. Here it is 9 and then minus 19 and then minus plus 22. Okay, so 22, and this gives a result of 34, and this is, I think, 10 to the power of 12. 10 to the power of 12. Okay, so this is Newton by Coulomb, or if you written is as 3.4 into 10 to the power 13 Newton by Coulomb. So this is the final answer, 3.4 into 10 to the power 13 Newton by Coulomb. Okay. So students, the next one is the second part of it, and when you do that particular one, you have to take into consideration the observation point is just here, and you have to calculate electric field at that point for the question number B. So the main problem is in that particular equation, what is the charge content inside the spherical part? So inside that particular spherical part, there is a proton of 4p within the nucleus, and there is 2s electron. So the net charge is 4p minus 2p, there is 2p. So E dot ds means this is the Gaussian surface. So 4 pi y square. Y square means this is 5.2 into 10 to the power minus 11. 4 pi y square equal to q inside by epsilon naught, and E equal to, so this is 1 by 4 pi epsilon naught into q inside means 2p, means you have to 4p minus 2e. You can write as 4p minus 2e by y square. So 1 by 4 pi epsilon naught, 9 into 10 to the power 9, 2 into p means, so the next part is electric field. This equal to 1 by 4 pi epsilon naught, that is 9 into 10 to the power 9, yes, and this is 2p by y square, that is 5.2 into 10 to the power minus 11, and this is square. So 9 into 10 to the power 9 into 2 into p means 1.6 into 10 to the power minus 19 by 5.2 into 5.2 into 10 to the power minus 22, and this gives a result of 1.1 into 10 to the power 12. Okay, so this is Newton by Coulomb. And I think students, you have clear. So what is about Gauss's theorem? I repeat again. If you have to calculate electric field, then you can take as E dot ds closed integration, and this is q inside charge by epsilon naught. Or otherwise, if you want to calculate the flux, then phi net flux, there is net flux equal to q inside by epsilon naught. Okay, so you have to take a Gaussian surface and how much charge is enclosed within that particular Gaussian surface. If you know what is the charge content within the Gaussian surface, then we can easily calculate the flat net flux, that you have to divide the epsilon naught, that is, and epsilon naught is value is 8.85 into 10 to the power minus 12. Okay, this is the magnitude, and the unit is Coulomb square by Newton meter square. Okay, so 8.85 into 10 to the power minus 12, you have to place it at that point. But when you calculate the particular numericals, first of all, you have to transfer this epsilon naught into 1 by 4 pi epsilon naught, so that you can place that particular value, that is 9 into 10 to the power 9. Okay, so the next question, you have to write down the next question. That is question number 14. That is question number 14. So question number 14. Write down the questions. Question number 14, and it is find the magnitude of electric field at a point 4 centimeter away from the linear charge distribution 2 into 10 to minus 6 coulomb per meter. Okay. So question number 14. First of all, students, you have to take a derivations, that is when a linear distribution of charge is given. Suppose it is a linear distribution of charge is given, and this is lambda equal to is given, that is lambda is given here, and there is 2 into 10 to minus 6, 2 into 10 to the power of minus 6 coulomb by meter. So this is 2 into 10 to minus 6 coulomb per meter, and you have to calculate electric field at that point, that is 4 centimeter away from this one. You can just apply the formula, that will be better. That is, electric field at that point is equal to kappa 2 lambda by r, and I established or derived that particular formula in the previous lecture. So if you don't know, or if you have not that particular knowledge related with how you can calculate electric field when a charge distribution, that is linear charge distribution, is given. So this is a linear charge distribution. When the charge is distributed over that particular linear or the line, then this is called linear distribution. When this is on a particular surface, that is called surface density, that is you have to take sigma and you have to take as lambda, and when it is within a particular volume, then you have to take rho. Rho is the charge density, volume charge density. So here it is the linear charge density, and you have to calculate electric field at a particular point due to this linear configuration. So kappa equal to, you have to know that is 9 into 10 to the power 9 into 2 into lambda. Where is the lambda? 2 into 10 to the minus 6. So 2 into, so this is 9 into 10 to the power 9 into 2 into lambda, that is 2 into 10 to the power minus 6 divided by r, 4 centimeter. First of all, students, you have a knowledge of unit system, in which unit system all the variables are given. So all the variables are given in SI system except 4 centimeters. So you have to transfer this one with a meter, that is 4 by 100, and k 2 lambda by r, since E is inversely proportional to r. We know that for a linear distribution. So this is the answer, and this is Newton by Coulomb. This is the answer. So this is Newton by Coulomb, and the answer is, you can cancel 4. So 9 into 10 to the power of 9 minus 6, that is 5, and 2 plus 2. 3. 9 minus 6, 3 and then 2, so 5. So 9 into 10 to the power of 5 Newton by Coulomb. This is the answer. So if a linear charge distribution is given and you have to calculate the electric field at a particular point, then you have just apply the formula electric field is equal to kappa 2 lambda by r, and then you get this one. Okay, I think it is clear, and write down the next one, that is question number 15. Question number 15. Okay, question number 15. So this is the last one. Question number 15, and I come back again for the another energetic and explanatory and conceptual numericals. There is 16 and 17. Okay, so this is question number 15, and the 15 number question is, long cylindrical volume contains uniform distributed charge of density rho. Yes, a long cylindrical volume. So you can consider this one as a cylindrical volume, contains a charge, where carries a positive charge of linear density. So linear density, you have to take lambda, this is 2.0, and this is 10 to the power minus 8 coulomb by meter. Lambda is given. Lambda means the charge is distributed linearly. Okay. An electron revolves around it in a circular path under the influence of attractive electrostatic force. Find the kinetic energy of the electron. Note that it is independent of the radius. Oh, yes. So note that it is independent of radius. So it is a cylindrical where that contains a linear charge distribution 2.0 into 10 to the minus 8 coulomb per meter, and you have to calculate, first of all, students, electric field at a distance r. Suppose you have to calculate, because this electric field can attract this electron along this direction, and this force, the electrostatic force, and the electron is free. What is the electron? The electron is revolving. What is about electron? The electron is revolving around that particular linear distribution of charge. Okay. So we know that when the electron is revolving, then there required a centripetal force. A centripetal force along this direction. This is centripetal force. Centripetal force. And this centripetal force is provided by the electrostatic influence between the electron and the linear distribution that can create the electric field. So this linear distribution of charge can create an electric field, and which is equal to kappa 2 lambda by r. Kappa 2 lambda by r. So the force is QE. We know that. What is about electric field? Electric field equal to force by charge. So what is about electric field? And you have to, when define that particular field, then you have to take a test charge. One, if we placed a test charge, a charge is given. Suppose there is a charge and it can create an electric field, and if we placed another test charge, then it can experience an electrical influence, and that particular influence is called electric field. So force per unit charge, test charge, is called electric field. So electric field is equal to 4 by Q0. Okay. So here the force is Q into E, and this force provides the centripetal force. What is the expression for this one? We know that this is mv square by r. Okay. So this is equation 1. The force is centripetal force, and this centripetal force, Fc, is equal to the electrostatic influence. This is equal to the electrostatic influence. So you have to write mv square by r. This centripetal force is provided by this force. So this is equal to QE. This is equal to QE, and E equal to this is 2 and this is 3. You have to equalize this and this one, and then put substitute in place of this E. So Q into kappa 2 lambda by r, and this is mv square by r equal to this one. So you can cancel r and r. That is the last final result is mv square equal to 2 q kappa 2 kappa q lambda. Okay, so 2 kappa q lambda, and this is the answer. So what is about it, students? Is it so the kinetic energy? What is about the kinetic energy? And you know that kinetic energy is equal to half mv square. So you can easily show that if you take half in both sides, then mv square, this is equal to half of this one. Half of this one means 2 and 2 cancel this one. So this is kappa q and then lambda. So half mv square, that is kinetic energy. So kinetic energy equal to kappa q lambda. So kinetic energy, from this equation, students, we can see that kinetic energy is independent of the radius. This radius and radius cancelize this one. So there is no dependence of kinetic energy on the particular radius. So kinetic energy remains same, and you can easily calculate this one. So kappa equal to 9 into 10 to the power 9. This is the proportionality constant of Coulombs. It is the proportionality constant of Coulombs law, and this is Q. Q means it is the electron. So 1.6 into 10 to the power minus 19, and this is lambda. So what is about lambda? So what is about lambda? And the lambda is given, given here. So this is lambda equal to a linear distribution, linear density 2.0 into 10 to the minus 8 is given. So 2.0 into 10 to the power minus 8 is given, and the answer is, this gives you an answer of 15. So question number 15, and this is 2.88 into 10 to the power minus 17 joule. 2.88 students, 1.6 into 2 means 3.2, and 3.2 you have to multiply this one is 9, 9 2 are 8, and this is 8, so you have to 28 point this, and this one is I think 16, and so when you place 2.88 and then it takes the form like that, 2.88 into 20 minus 17. So all the numericals, students, all the numericals means question number 13, question number 14 and question number 15 is completed, and there is still up to 24, question number 24. So there is 1 2 3 4 5 6 7 8 9, there are 9 number of questions are left, and I solve all the numericals within 2 or 3 days. Okay, so stay with me, and last of all I want to say, continue your study, and if you think that this is a particular channel and the concepts are really very beautiful and wow the concepts, then you can subscribe my channel and stay with me. Thank you.